property and some perfect square trinomials.
Okay.
So number one is...
One second. Just, I always forget to do this. Try this. This probably works better. All right.
It would be x squared minus 6x minus 11 equals 0.
You're supposed to solve it by completing the square?
Yes.
Okay. What I do on these is always move the number to the other side, like that as your first step,
Okay.
so that the left side of the equation has only the two x terms. And then what we're going to do is complete the square on the left side. Do you know how to complete the square?
No.
You take half of the coefficient of the x term and square it.
So it'd be 3 squared?
Yeah, and it's always added.
Okay.
And when you add that to the left side of the equation, you have to balance it out by adding an equivalent amount to the right side.
Mm-hmm.
And then you will always be able to write the left side as x minus whatever you got when you took half, quantity squared, like that. With me?
Yes.
The key to doing these is to make sure that when you go from line 1 to line 2, you have not changed anything. Going to line 3, I have not changed anything. Now I can do what to solve this problem?
Take factor out a square root.
Take the square root of both sides. So what does that give you on the left?
6 minus 3.
X minus 3?
Oh yeah, x, sorry.
And what does it give you on the right?
Square root 20, which is 2 square root 5.
However, whenever you take the square root of both sides of an equation, always begin your answer with the words plus or minus. You see why? Here, let me give you an example. Up here in the upper right, can you see that?
I can now.
X squared equals 4. Can you see that?
Yes.
Okay. To solve that, I would take the square root of both sides, right?
Mm-hmm.
It's plus or minus 2. And notice why minus 2 is an answer. If you square minus 2, you get 4.
Mm-hmm.
If you square plus 2, you get 4. So when you take the square root of both sides of an equation to solve for it, you always have the plus or minus. Now, back to the original problem, I want to solve for x. So I'm going to move the 3 over, and I'm going to put it in front, not after. The reason I do that is because that looks very similar to the answers you see when you use the quadratic formula, correct?
Mm-hmm.
It's always a plus or minus. And in fact, had we applied the quadratic formula to line number 1, that's exactly what we would have gotten. 3 plus or minus 2 root 5.
Mm-hmm.
Okay? All right, let's do another one.
Okay, this one is x squared plus 6x minus 5 equals 0.
Okay, I'm going to put the 5 on the other side to begin with.
Mm-hmm.
And now I'm going to put parentheses, and I'm going to leave room to complete the square inside the parentheses. So what's the next step?
Take half of 6 and then square it.
Okay, and then add it.
To the other side?
To both sides.
Okay.
And that's going to guarantee that I can write the left side how?
As a quadratic?
As a binomial term.
Oh.
In other words, we're starting with a trinomial term. But because we created it by completing the square, I'm always going to be able to write this as x plus 3 quantity squared.
Mm-hmm.
Always. As long as you created that above expression by completing the square. Just add those two numbers. Now what's the next step?
Take the square root of both sides.
Give me the next line.
So it would be x plus 3 equals plus or minus square root 14.
Good. And the final answer?
So it would be x equals -3 plus or minus square root 14.
Yeah, I don't know how important it is to write it in that order. I doubt that you would lose points if you put that -3 seconds. But there is a certain elegance to putting it first because it matches what you would get if you had used the quadratic formula. Okay? These can be a little tougher. Go ahead, keep going. Let's do them until you can do it the whole thing on your own.
This one is x squared plus 3x minus 1 equals 0.
Like that?
Yes.
Okay, now?
So you take half of 3, which would be 3 over 2.
Okay, that's the good way to do it. Don't make it 1.5, make it 3 over 2. Because it's easier to square 3 over 2. What's 3 over 2 squared?
9 over 4.
So I got to add 9/4 to the right side. Now how can I write the left?
X squared plus...
No, it's just the inside the parentheses is going to be a binomial first degree polynomial. In other words, it's always going to be an x plus or an x minus, whatever you got when you took half of that. And it's always the same sign as that. If that had been minus 3x, then it would be minus. But since that's plus 3x, it's a plus. What goes next?
3 over 2.
Okay, what's 1 plus 9/4?
1 and 9/4.
Let's put it in an improper fraction. How do we add those two together so that we get a single ratio?
You do 4 over 4 plus 9 over 4. So you would get
13/4.
Yes.
Okay. So now what?
You do the square root on both sides. So it'd be x plus 3 over 2 equals plus or minus square root 13/4.
Can you simplify what's on the right side at all?
Can you do the square root of 4?
Yes, you can. But first you need to say that that whole thing is equal to the square root of 13 over the square root of 4. So the right side becomes plus or minus root 13 over the square root of 4, which is 2. And I'm going to move the 3/2 over. And now I could write that in a couple of ways. I can write it exactly as I've written it there. Or I can write it like this. -3 plus or minus root 13 over 2.
Mm-hmm.
Which is also the way you would see it if you had applied the quadratic formula. It would come out exactly like that.
Okay.
Okay?
Mm-hmm.
Do you have any where the coefficient of the x squared term is not 1? Make sure we cover at least one of those.
Yes.
Okay?
It is 3x squared minus 3x minus 4 equals 0.
Okay, now I'm going to start out doing the same thing. But there's a problem in that you cannot complete the square until you get the coefficient of the x squared term to be 1. So what do I have to do?
You can pull out a 3.
I can factor out a 3.
Oh, can you pull out a 3x?
No, you don't want to do that. You just want to pull out a 3. In other words, remember, my goal is to still complete the square inside the parentheses. So I don't want to pull out a 3x. You could, but I don't want to do it. Now complete the square inside the parentheses.
X over 2 is just...
It's not x over 2. It's what's the coefficient of the x term?
Oh, 1.
Okay, so it's 1 over 2 squared.
Which is 1 over 4.
Now, at this point, everything's the same as line 1, right?
Yes.
Okay. The moment I write plus 1 over 4, how much did I add to the left side of the equation?
1/4.
No, look at it again. What's that 1/4 being multiplied by?
Oh, 3, because it's on the outside.
So I really added 3/4. And that's the difference in these problems, is you have to take that into account. In other words, if you have to factor out a number, then whenever you write inside the parentheses, you have to multiply that thing by whatever you factored out. Okay, so now let's continue. How can I write that? What's inside the parentheses?
3x minus 1/2 squared.
Like that. What's the right side?
19 over 4.
What's the next step?
Would it be take the square root of both sides?
Not yet, because you want to leave that until you've isolated everything. That 3 is not being squared.
Oh, so you do 3x minus...
No, you divide both sides by 3. That will get rid of that 3. In other words, I'm going to divide this side by 3, and I'm going to divide this side by 3. Now I've got x minus 1/2 squared equals 19 over 12. Now what?
Now you factor out the squared.
Now you take the square root of both sides. Plus or minus root 19 over 2 root 3. Yeah.
Okay. And your answer would be x equals 1/2 plus or minus square root 19 over 2 square root 3.
Well, not quite. But yes, actually that is in my book, that's an acceptable answer. What's wrong with it?
And the 1/2 and the 2 root 3.
Well, here, let me write that the way you said it. Let's see, that was root 19 over 2 root 3, correct?
Yeah.
Okay. What's wrong with that answer?
You could do,
it's got an irrational denominator. Okay, the root 3 is a divisor. So you want to rationalize that. Do you know how to rationalize a fraction? If I gave you a fraction over here on the left, here, let me give you a simple one. What if I had that? How can I change that so I no longer have an irrational denominator, yet I still have the same number?
You would multiply both by 2 over 2?
By root 2 over root 2. Not by 2 over 2. That won't get rid of it. But if I multiply it by root 2 over root 2, then I've got the irrational in the numerator. That is equal to that. Except it's more mathematically accepted. Mathematicians don't even like the concept of dividing by an irrational number. If you think about division, it's supposed to be splitting up something into a number of parts, right? You divide something by 3, you're dividing it into 3 equal parts. Well, how do you divide something by an irrational number? You don't. However, if you put both of these in a calculator, what I have circled, you get the same answer. It's just the one on the right is rationalized. So how do I rationalize this 19 or root 19 over 2 root 3?
You'd have to multiply the top and the bottom by 2 root 3.
Just root 3 will do.
Oh, okay.
In other words, you want to do it as simply as you can. I could also do it by 2 root 3. I can, you can multiply any fraction by the number 1. And that's what root 3 over root 3 is the number 1. And what that gives us is root 3 times root 19.
19 times 3 is
57.
57.
And the bottom becomes what?
6.
Now, is 57 simplified?
You can take out a... I think it is simplified.
It is. And if you look at how we got it, we multiplied a prime number by a prime number. When you multiply prime numbers together, you always get a number that does not have any other factors. So 57 is got one set of factors only. That's 19 times 3. None of those is a perfect square. So this would be an acceptable answer. What would be another acceptable answer? I wanted to make it look exactly like what I would get from using the quadratic.
You could do 1 plus or minus 57 all over. Oh, you have to make a common denominator.
Okay.
So that would be 6.
Okay.
It would be 3 plus or minus square root 57 all over 6.
Yeah, that would be a little nicer answer. And again, I don't know. You might get 100% credit with that answer there.
Mm-hmm.
I suspect you would lose a point if you gave that answer there, where you have an irrational denominator, even though it's the same number if you put it into a calculator. It just all depends on your teacher and your class.
Mm-hmm.
Okay, what else? Those you always have to, whenever you have a coefficient in front of the x squared term, you always are going to have to factor it out, even if it doesn't factor out. Let me give you a hypothetical here. How would you complete the square on this one?
It would be +4.
Give me the next line.
It would be 3x squared plus 4.
Hold on. You need a parentheses. In other words, the very first step is to get rid of that 3. And the only way to get rid of that 3 is to factor it out. So it leaves x squared there, but what's the rest of it?
3x, parentheses x squared plus 4/3.
Yeah. In other words, that's the tricky part. You're not used to factoring stuff out when it doesn't divide evenly. And when you're completing the square, that's not a consideration. You have to factor it out before you can complete the square. So now I haven't changed anything. So now what do I do?
You'd have to take half of...
Okay. What's that?
That would be 4/6, so 2/3.
Okay. So what am I going to add?
To multiply it by 3.
Hold on. It's not 2/3. It's 2/3 squared. In other words, you have to take half of that coefficient, which you did to get 2/3.
Oh, yeah.
But then you got to square it.
So it'd be 4/9.
Right. Now how do I balance it on the other side?
You'd have to do 4/9 times 3/1.
So that's 12/9. So I've got to add 12/9 to it.
Mm-hmm.
And then the rest, okay, let's finish this. How can I write what's inside the parentheses?
3x plus 2/3 squared equals 30/9.
Okay, now what?
You have to divide both sides by 3.
Okay, that gets rid of that 3 and makes that a 10.
Mm-hmm.
And now x plus 2/3 equals what?
Equals 10/3.
Root, plus or minus, first of all. Root 10/9.
Mm-hmm.
What's your final answer?
It would be x equals 2/3 plus or minus
Hold on.
square.
When you move that 2/3 over, you got to change its sign.
Negative 2/3.
Okay.
Plus or minus square root 10/3.
Good. And now you can put the denominators together as one denominator, which is kind of funny because I made this problem up right out off the top of my head, and I didn't realize I was going to end up with a nice fraction to take the square root of, 10/9.
Yeah.
Okay. What else?
We have one where it is 3x squared equals 6x minus 1.
Yeah, you do this one for me. Start. And
So
you're supposed to use complete the square, right?
Yes.
Okay.
So you'd have to move the 6x over, so it'd be 3x squared minus 6x equals -1. And then you'd have to pull out a 3.
Tell me in the next line.
So it would be 3 parenthesis x squared minus 2x equal end parenthesis equals -1.
Yeah, and it's always a good idea to move this, to leave room, like I just did there. When you're doing it on paper, you want to do exactly the same thing because you have to fill in the blank spot. So what's next?
And then you do half of 2, which is 1, and square it, which would also be 1. And then on the other side, it would be plus 3.
Right. And notice that's important because I need that right side to be positive. If that right side stays negative, I'm going to have a real problem when I go to take the square root of both sides. I'm going to end up with an imaginary number. Okay, what's the next line?
It would be 3x minus 1 squared equals 2.
Next line.
Then you divide both sides by 3. So it'd be x minus 1 squared equals 2 over 3.
Keep going.
And then you take the square root away from x minus 1, so it'd be x minus 1. And then to the other side, it would be plus or minus square root 2 over 3. And then...
Yeah, let's just look at that radical for a minute. Whenever you have the square root of a fraction, what is that going to become? In other words, what's the first thing I can do to try to simplify square root of 2/3? It's square root of 2 over square root of 3. But that's irrational, so how can I rationalize that?
Then you can multiply square root 3 by the numerator and denominator.
So that gives me square root of 6 over 3. So what I've written down there is actually square root of 6 over 3. Let's change it to that.
Okay.
Square root of 6 over 3. Move the 1 over as a positive 1.
So it would be x equals 1 plus or minus square root 6 over 3.
Will your teacher accept that? I mean, I would think he would. That's the correct answer.
Yeah, but we can also go one step further and make 1 over, it would be 3 over 3. So it would be 3 plus or minus square root 6 all over 3.
Like that. And whether or not you need to take that last step, I really have no idea. Whether your teacher would want you to take that last step or not. Because it didn't sound like there were any instructions that said, make it look like you've used the quadratic formula. They just have asked you to solve it. And that's as good a solution as any. You definitely want to rationalize that denominator. In other words, you don't want to give answers that have a radical in the denominator. Not until you get to trig. Believe it or not, are you taking trig next semester?
Yes.
When you get to trig, most trig teachers nowadays throw out the need to rationalize the denominator. And there's really good reasons for it that I won't go into now. But so it kind of depends on where you're going to school as to whether they'll make you rationalize it when you get to trig. And who knows? Maybe they don't care about rationalizing it even now. I don't know. You'd have to take that up with your teacher. You'll probably find out at your next class as to whether these would need to be rationalized like we're doing. But it's always going to be the case. In other words, same thing if you take square root of 1/2, that's the same as 1 over root 2. That needs to be rationalized. So whenever you have a fraction, first of all, split it up into the numerator, the root of the numerator over the root of the denominator, and then figure out whether you need to rationalize it.
Mm-hmm.
Okay. Is Jessica doing half hour also tonight?
Yeah.
Okay. Well, it's 7 if you want to get her.
Okay. All right, ready?
Okay.
Hi, Jessica.
Hi.
How are you tonight?
Not bad.
Good. So, what do you got in the way
Same
of
type of problems.
Similar stuff?
The same stuff.
Okay. Got different problems or the same ones? It doesn't really matter to me.
If he did his homework with you, then it's the same problems.
Okay. Why don't you give me ones that you want to, that you pick. So which ones you want to do?
Okay. Let's do 3 times x plus 4 squared. Yeah. Equals 21.
Okay, what's the first step there?
I divide both sides by 3.
Yeah, you don't want to take the square root of both sides because that 3 you need to get rid of it before you take the square root of both sides. So the next line should be this, and then once we've isolated what's being squared like we just did, now you can take the next step, which is?
You square root both sides.
What's the next line?
So it's, which is x plus 4 equals root 7.
Whenever you solve an equation by taking the square root of both sides, you must start your answer with the words plus or minus.
Oh, yeah.
That's what everybody forgets, and you will lose points. That's 2 answers, in fact. And so you've lost one of them if you just say plus. And the last line?
That would be x equals -4 plus minus root 7.
Yeah, I usually put that number first because this looks very much like the kind of answer you get when you use the quadratic formula. And you could use the quadratic formula on this. In other words, if I want to square that out and make it all one quadratic, I could apply the quadratic formula. This is exactly the answer I would have got.
Okay.
All right. What else?
X squared minus 6 minus 11 equals 0.
That was minus 6x, correct?
Just 6.
No way.
Oh, no, you're right. My bad.
It's all right. And your job is to solve this by completing the square, correct?
Yep.
Okay. When you're completing the square, when you're doing a traditional quadratic, you like to have everything on one side and 0 on the other. I was going to factor this, but I quickly realized I can't factor it. There's no factors that work. So I've got 2 ways to solve this. I can do it by using the quadratic formula, or I can do it by completing the square. If I'm going to complete the square, then I want to put my number on the other side.
Minus 6x
Like
equals 11. Okay.
Now, the one thing you want to pay attention to when you're completing the square is that you do not change the equation from line 1 to line 2. And when you go to line 3, it has to be the same. You're not allowed to change one of the sides of the equation without making the same change on the other side.
Okay.
Okay, so how I'm going to complete the square, I'm going to draw parentheses around the x squared and the x term, and I'm going to leave enough room to write. And what I'm going to write is half of 6 squared.
Half of 6 squared is 9.
And it's always plus.
Okay.
Since I just added 9 to the left side, I got to add 9 to the right side.
Yeah. So that's
Now, because I completed the square, I'm actually able to write this as a linear binomial term squared. In other words, this will always come out to be x minus 3.
Minus 3 squared.
And it'll have the same sign as that. The right side becomes 20.
Yep.
Now I'm ready to go for it. What's the next step?
So square root both of them.
Give me the next line.
So it's x minus 3 equals root 20.
Plus or minus.
Plus minus root 20.
It's a hard thing to remember. I forget it half the time. My students forget it about 90% of the time. And you will lose points if you forget it. So plus minus root 20, what's a simplification of root 20?
4, wait a minute, hold up. 2 root 5.
There you go. And the last line, x is equal to what?
X equals negative 3 plus minus 2 root 5.
Okay, is it negative 3?
Yes. No, it's positive 3.
Positive. The way I like to do algebra is if I am moving a number that is being added or subtracted to something, I just do it. I don't do the way they teach you to do it. The way they teach you to do it is add 3 down there to get rid of it, and then add 3 to the right side. Well, the way I do it is if I'm going to move a number over to the other side, I just move it and change its sign. So you always got to change the sign. And that's why it becomes positive. And that's your final answer. And that's exactly what you would have gotten if you'd used the quadratic formula also.
Okay.
Let's do another one like that, and I'll have you do the whole thing. And when I say like that, make sure that the x squared has a coefficient of 1. When that coefficient is something other than 1, it's a little bit harder. But let's get the easy one down first.
Okay. So the next one that I have for homework is x squared plus 6x minus 5 equals 0.
Okay, work me through every step of this.
Okay.
Just read each line. You don't even have to tell me what you're doing. Just read the next line.
Next line is x squared plus 6x
Remember what that first step is. To move the number to the other side.
So equals 5.
Okay. Now, what's the next step? What do I want to do with that x squared plus 6x?
You want to make it a perfect square.
Okay. So really the first thing I want to do is add parentheses like that, leaving enough room to complete the square.
Which should be 9.
Okay. So it's plus
It's a plus.
9. Got to add it to both sides. Now how can I write the next line?
Then I just do x squared plus 6x plus 9 equals 14.
Okay, now the next line.
And then you factor. So then that would be x minus 3 squared.
It's actually plus. It's whatever the sign in front of that 6 is.
Okay, and then equals 14. Then you square root both of them. So it's x plus 3 equals root 14.
Equals plus or minus root 14.
Plus minus.
It's okay. It takes a while. I wish there was a song or something. That's why I try to tell every student, whenever you're taking the square root of an equation, make sure you start your answer with the words plus or minus. Because it's always the case. You always have to start your answer with the words plus or minus. And what's the final answer?
X equals -3 plus or minus root 14.
And root 14 is simplified?
Yes.
Yes, it is. It can be root 7 times root 2, but there's no way to pull out a whole number. So you don't simplify it when that's the case. Okay, I think you've got that down. You have one that has a number greater than 1 as the coefficient of the x squared.
Okay, here's one.
Okay.
2x squared plus 5x minus 3.
Minus what?
3.
Okay, I'm going to go ahead and put that over on the right side right now. Now, here's the thing. You cannot complete the square unless the coefficient of the x squared term is a 1. So I cannot complete the square on this until I factor out a 2.
Because you just divide both sides of the equation by 2?
No. You don't want to divide the right side. It's all I want to do is factor out a 2 from the expression on the left side, which gives me this.
So x squared plus 5 over 2.
Yeah. In other words, you're not used to factoring out numbers unless they divide evenly, right?
Yeah.
When you're completing the square, you have to do that. In other words, it doesn't matter whether 5 is divisible by 2 or not. You still have to divide it.
Okay.
Okay. Now, what am I going to write to complete the square?
So isn't it half of that term squared?
Yes. So what is that?
That's 2.5 over 1 squared, which is...
Don't use proper fractions ever, I'm going to say. Well, not ever, but 99% of the time you're better off with an improper fraction.
So that's just 25 over 4.
It's hard to square 5/4 unless, it's hard to square 1.2, which is what 5/4 is, and it's hard to square 1 1/4. Try squaring 1 1/4 without putting it as an improper fraction. It's hard to do. So I'm going to make this 5/4 squared, which is what?
5/4, is it 5 halves?
No, remember I'm taking half of it.
Oh, right. So then that's 25 over 16.
Exactly. Now, how much did I just add to the left side of the equation?
25 over 16?
No. That 25 over 16 is being multiplied by that original 2 that I factored out. Right? Didn't I really just add 50?
And it's 5 halves?
No. It's unfortunate that they used a 2 here because it makes it more confusing. It'd been a little clearer if they'd have used a 3. Let me back up a second.
Okay.
So far, these two lines are the same. Correct? And what you want to do when you're completing the square, every time you write a new line, you should check and make sure you haven't changed anything. At this point, I have not changed anything. So all I've done is factor a 2 out. Now, I've got to complete the square inside the parentheses. So I have to take half of 5 halves, which is 5/4. I have to add it squared, which is 25/16. But when I just wrote in that 25 over 16, I didn't add 25/16 to the left side. I add twice that. I added 50.
50 over 38.
Oh, just over 16.
Over 16. Oh, yeah, my bad.
In other words, I'm multiplying the 2 times the 25 over 16, which I can write as 50 over 16. All right, or I can simplify that a little bit. Let's see, that's 25 over 8. Let's write it like
Yeah. Okay.
just to make it a little simpler, 25 over 8. But what's important is that you don't balance by the number you wrote. You balance by the amount you added to the left side of the equation. That's the key.
Okay, so our teacher said not to simplify the second fraction, especially because there's 16 on the bottom, because 16 is a perfect square, and it'll make it easier when you square root that side.
You're right. So let's take that back and make it 50 over 16.
Okay.
Because now you're absolutely, well, not really, because we're going to divide this all by 2. So I'll leave it like this for a moment. No, let's take it back to 25/8. You'll see what the problem is here. Okay, so now the next line is what?
And then the next line is 2x squared plus 5 over 2.
What goes inside the parentheses? It's a linear term. It's not x squared, it's just x.
Yeah.
X plus what?
X plus 5 halves.
5/4. Whatever you got when you divided this coefficient by 2.
5/4 squared.
Right. And I'm going to go ahead and combine these, despite what your teacher said, because you'll see why. 3 is 24/8. So that is the improper fraction. Now what's the next step?
And then the next step is square rooting both sides. Well, actually,
Got to get rid of that 2. That 2 is not being squared, so you don't want to take the square root of that.
So you divide them by 2.
Yeah, so if I divide it by 2, it gets rid of that and turns that into 16. Now I got your perfect 16. In fact, I got a numerator and a denominator that are both perfect squares.
Awesome.
So what's our next line?
Our next line is x plus 5 over 4 equals.
What are the first words?
Equals plus or minus root 49 over 16.
Which is 7/4. Root 49 is 7 and root 16 is 4. What's the last line?
So that's x equals negative 5 over 4 plus or minus 7/4.
Okay, now I can do something with that.
Did you put it all over 4 on the right side?
Make it a single denominator, and you're going to discover that we have 2 fractional answers that we can give without a radical sign. In other words, this means minus 5 plus or minus 7
over 4.
Well, if I take the plus, that's 1/2. And if I take the minus, it's minus 7/2. I think, well, let's see, minus 12/4 is 6/2. That's minus 3. Right? Yeah, minus 12 divided by 4 is minus 3. So here's my 2 answers right there.
Oh, cool.
Yeah. Yeah, because usually you're going to have a radical sign. It's only because they set this up to make those both perfect square numbers. But that's what you have to do when you don't have a 1 in front of the x squared.
Okay.
And it definitely makes it a little harder because that's a mistake waiting to happen, where people want to balance the other side by adding 25/16, and you have to add twice.
Okay.
Got another one like that?
Yeah.
Well, hold on one sec. Hold on one sec. Dog suffers from seizures, and she's just going into one right now. Yeah, it is kind of sad. She has about one a day. They last about 15 minutes or so, but it just completely locks up.
I'm sorry. That's
okay. What else you got?
3x squared minus 2x minus 2
Equals what?
minus 2 equals 0.
Okay, so I'm going to write it like this.
That's equals plus 2, yeah.
Yeah, I'll skip the first thing and jump straight to there. Now you tell me everything to do from here forward.
Okay, you're going to take the 3 out. So it'd be 3 parentheses x squared minus 2x, and then leave space.
Hold on.
And the parentheses.
When we factor the 3 out, we have to factor it out from every term.
So then it'd be 2 over 3.
Yeah.
X. And then leave a space equals.
Now, check to make sure we didn't change anything. In other words, is line 2 the same as line 1?
Yes.
Yes, it is. Okay. Now you're ready to complete the square inside.
So that's 3x squared minus half of 2/3.
Which is?
Squared. So that's 2/6.
Okay, simplify that before you square.
1/3 square is 1/9.
So squared is what? What do I write here?
Plus 1/9.
And then what do I balance with on the other side?
Plus 1/9.
No. When I wrote 1/9,
Plus
I
double.
didn't add 1/9 to the left side of the equation. I added 3/9.
3/9.
So I got to add 1/3 to the other side.
But if it's double 1/9, wouldn't that just be 2/9?
It's not double, it's 3. We factored a 3 out. Notice that 1/9 is being multiplied by 3.
Okay.
So that's what I added. The moment I wrote 1/9 on the left side, I added 3/9 to the left side of the equation.
Okay.
So I balance it by adding 3/9 to the right side. Okay, and then I'm not sure what your teacher was referring to when he said don't combine those. I think you need to, because I've got to divide the right side by 3. And it's really hard dividing a proper fraction, like 2 1/3. So I'm going to turn that into what? What's 2 1/3 as an improper fraction?
2 1/3, that's 7/3.
Okay, let's make that read 7/3. Now what's the next step?
7/3. Okay. Next, you would divide by 3.
Yeah, I would as the next step. So I'm going to cancel out that 3, and I'm going to turn that into a 9. See what I did?
Yes.
Okay, so let's rewrite it now.
So it's x squared minus 2/3 x plus 1/9.
Okay, and how can I write that as a linear binomial term?
You do x minus 1/3.
Yep. And then the whole thing squared.
Yep.
And that's equal to 7/9. I can go from line to line to line and not changed any of the equation. I've just rearranged it, rewritten it. So what's the next line?
So then that's x minus 1/3 equals root 7 over root 9, or root 7/9, which you can change to root 7 over 3.
Okay.
So the last line is x equals 1/3 plus or minus root 7 over 3.
Yeah, that should be satisfactory to your teacher. You could also, if you wanted to, write that as 1 plus or minus root 7 all over 3. And this is the kind of answer you would get if you'd have plugged it into the quadratic formula. But the left circled one is just as valid of an answer. I just haven't combined the numerator. Or haven't combined the denominators.
Okay.
Okay?
Yeah.
All right, what else? Got about 5 minutes. We can probably have just enough time to do one more.
Okay. Let me look.
Find the hardest one you got.
We have, they're all pretty much the same thing.
Okay, let's just pick one and we'll do one more. Pick one that's got a number in front of the x squared, other than 1.
Okay. How about 5x squared plus x minus 2 equals 0.
Okay, work me through every line of it. Just read it.
Okay. So then you do 5x squared plus x, leave space, equals 2. And then put parentheses around the left side.
Okay.
And then you take out the 5.
Okay.
So
yeah, you absolutely cannot complete the square until that's a 1.
Yeah. X squared plus x over 5.
Let's write it like this. Because remember, we're going to have to take half of that number.
Oh, and you can't take half of the x, yeah.
Well, x over 5 is a little harder to divide by 2 and square. In other words, we're only dealing with the coefficient of x. And when you write it x over 5, that's the same thing as 1/5 times x.
Yeah, because the coefficient of x is 1.
Yeah, exactly.
Okay. And then the other side would now be 2 over 5?
No, I didn't do anything to the right side yet.
So you just leave it as 2?
I do. In other words, the only thing I did was factor out a 5 from the above line on the left side only, which means I haven't changed the left side. Notice in line 3, the left side is exactly the same as the left side in line 2.
Just, yeah. Okay.
Next step.
And then you do, did you take out the 5? Can you divide both sides by 5 now, or should I complete the square?
No, you can actually do it either way, I think. But that's not, let's go ahead and, see, that gives you 2/5 on the other side.
Yeah.
Is that what your teacher does? Is that the steps he does? He or she? Or do you complete the square first? The way I've been teaching it for a long time now, it just occurred to me that maybe this is not the best way to teach it. I think you could divide by 5 right now, and then you'd complete the square, and whatever I wrote in, I could balance with the same number on the right side. Whereas the way I do it is a little different. I complete the square first.
Okay. So then let's do that.
Let's just be consistent and do it that way. I do think the other way probably gives you the same answer. But let's do it the same way. So what am I writing in right there?
So then it'd be half of 1/5 squared. So that's 1/10
Okay.
squared is 1/100th x.
Not x, just 1/100th.
Okay.
Okay.
Now we can divide both sides by 5.
Not yet. I just added a blue number to the left side of the equation. I can't do anything until I balance it on the right side.
Oh, so then plus 1/100th.
It's not how much I added on the left side. How much did I add on the left side?
You add 1/50th.
Well, how about 5/100ths?
5.
Yeah,
Oh,
just
because
multiply
it's 5. Yeah.
I mean, we can simplify it later. That's what I added, is 5/100.
Yeah.
Now,
So now the 5.
yeah, we can now, well, we got a couple things we need to do here. Let me just do this. That is 205 100th, I think, isn't it? Yeah.
Yeah.
Okay, and now we can divide by 5, right?
Yep. So that's x squared plus 1/5 x plus 1/100th equals.
Hold on. How do I write this as a binomial? I've divided both sides by 5.
So then that's just x plus.
It's what you got when you took half of that coefficient.
Half of that is 1/10.
Yes.
It's
That
1/10
squared equals that.
Equals.
And it always will. In other words, that's the whole point of completing the square, is that you're going to be able to write that trinomial as a binomial linear term squared.
Okay.
Okay. Next step?
You'd have to divide the other side by 5, so that'd be 4.
I already did that. I turned the 100 into a 500.
Okay.
In other words, we've got this as our current line that we're working on.
But wouldn't you be dividing that by 5, so it'd just be 41 over.
This up above was equal to 205 over 100. And I had to divide that by 5. And that's how I got 205 over 500.
Oh. Okay.
Okay, in other words, there's a 5 up here. And the right side is 205 over 100.
Yeah.
Yeah, just give me 1 second here.
Fine.
Safe when she can go find a dark spot. She's extra sensitive to the light when she has a seizure. Okay, so what's the next line? X plus 1/10 equals what?
Equals root 205.
What do you start your answer with? What words?
Plus or minus.
Yeah, let's go ahead and do this. 205
over 500. Yep.
And now we move the 1/10 over.
So x equals negative 1/10 plus or minus root 205 over root 100, 500.
Yeah, and that looks like 5 times root 10, isn't it? Let's see.
5 times. Well, maybe.
No, hold on. For some reason, my mind's going blank here. Oh, I can take a 10 out. So it's 10 root 5.
10, okay.
Right?
Yep.
So I can make that look like 10 root 5. Same as root 500.
Yep.
Okay. Now I got a problem because I have an irrational denominator.
And then you
rationalize that?
Wouldn't you just multiply top and bottom by root 5?
Yep. So now we got minus 1 over 10 plus or minus root 1025 all over 50, right?
Yeah.
That's a...
Wait, no, wouldn't it just be 10? Because just the root 5s cancel out?
They don't cancel out. Root 5 times root 5 equals 5. And then I got to multiply it by
5 times 10 is 50.
Yeah. Now, I can simplify the top. Because the top, I think I can.
Probably.
Gee, it's not as easy as I thought it was going to be, though. I got to believe I can pull a 5 out of there.
Yeah, so that'd be 5 and
5 and 2.
5.
2. No, that would be 5 and 205.
Yep.
205. I'm not sure 205 simplifies. Does it? I don't think it.
Well, you could take out another 5, and then that'd be 45.
You'd have, oh, this thing is divisible by 25. You're right.
Yeah.
And so if I divide the numerator by 25, I get 41 times 10. So I think I can write this as 5 root 41. And then that 5 cancels with that 5. Now my final answer is going to be minus 1 plus or minus root 41 all over 10.
X equals.
Follow all of that?
Yeah.
The arithmetic gets a little hairy at the end when you end up with things like that have to be rationalized.
Yeah, but then you just have to simplify, which isn't too hard.
Exactly. Rationalizing and simplifying is not that hard, but it's kind of hard when the numbers are big. I had a hard time doing it with 1,025. It probably would have been safer to just figure out how to. No, I'm not sure that simplifies. It doesn't. It doesn't simplify until you turn it into 1,025, and then you can simplify it. Yeah.
Yeah.
That's really the only way to do it here. Okay. Jessica, I will let you go. I think I've probably taken you over by a few minutes. I apologize for that. Have a good evening. I'll talk to you next time.
Yeah, you too.
Bye-bye.
Thank you.
Mm-hmm.